Okay, so this is our third and final video for our flipped class and lesson on basic combinatorics. And in this video, we're going to be talking about the number of ways that we can select a smaller group from a larger group where order matters and where order does not matter. So we've already said that a permutation is an arrangement of items in a particular order. And we're going to say the number of permutations of n items of a set arranged r selected items at a time is going to be given to us by this equation right here. So right here we're saying basically we've got a larger group of n items, and we're taking r items from that group and arranging them in a particular order. So this is all the ways we can take our items from n items and arrange them in a particular order. And what we're seeing here is the n is coming first. It's npr, and right here we have that n in our formula right there and right there. And the number of items we're selecting, r, is going to be in our formula right there, giving us n factorial over n minus r factorial. Okay, so right here what we want to do is take a look at an example. We have 7 swimmers are racing in a heat, and a heat is a race of swimmers. What is the total number of possible ways for 3 of the swimmers to finish first, second, and third, right? So right here when we're talking about finishing first, second, and third, that's an arrangement of 3 of the 7 swimmers, right? So basically right here, we can say that we're going to be selecting 3 from the 7, right? The n value, of course, is going to be 7, and that's the number we're selecting from. And the r value is going to be 3 for the first, second, and third place, right? So right here, that gives us 7 permutation 3. And what I want you guys to try to do right now is go ahead and set up this equation, right? So we're using this formula right here, and I want you to go ahead and set that up, and we will come back and look at this in a second. All right, so for our n factorial over n minus r factorial, we have 7 as the number of swimmers swimming in the race. That's 7 factorial over 7 minus 3 factorial. And when we're evaluating this, we're going to basically do our subtraction first and then evaluate the factorial in the denominator. So that'll give us 7 factorial over 4 factorial, right? And right here, we can proceed and get a number by expanding out our factorials, right? So we know that a factorial is basically going to be an incremental multiplication, right, where we're basically going down and multiplying in decreasing order from integers. So if you've got 7 factorial, that's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is going to be 4 times 3 times 2 times 1. So right here what we can see is that we have the multiplication of 4, 3, and 2 in the numerator and denominator. So those are going to cancel, and that's going to leave us with 7 times 6 times 5, which gives us 210 possible first, second, and third place arrangements from our race of 7 swimmers. So right here what we want to do now is take a look at that multiplication that we're evaluating in the end, 7 times 6 times 5. And really what we're seeing here is a multiplication principle of counting, right? We have 7 ways for a first place swimmer to finish, right, from our 7 swimmers. And then right here, after we get a first place swimmer, there are 6 swimmers that could potentially get second place, right? So 6 possibilities for a second place swimmer. And then after we get a first and a second place swimmer, there are going to be 5 possible swimmers that could get third place, right? And that, of course, is giving us our 210. Now, right here, what we're saying is that we want to know how many ways we get first, second, and third, right? So we don't care about the last 4 swimmers, right? And basically, that's what permutation is giving us, right? When we evaluate 7 factorial, that's all of the ways that all 7 swimmers can finish the race, right? So what we want to do when we're just interested in first, second, and third is divide out the number of ways those last 4 swimmers can be arranged for each of the ways we can get first, second, and third. So right here, that's our 4 factorial in the denominator, which we get from, say, taking 7 and subtracting our 3 away, right? So that 4 factorial is basically the number of ways that the last 4 swimmers can finish after we get first, second, and third, right? And we divide that out of the numerator and denominator and get our 210. That's the number of ways we can get first, second, and third. Okay, so this is selecting or that was selecting, permutations is selecting a smaller group from a larger group where the order of that smaller group matters. We're going to say that a combination is a selection in which order does not matter. So right here, the number of combinations of n items of a set chosen r items at a time is going to be given to us by this equation, right? Where we're selecting from a larger group of n r items, right? And basically right here we're seeing there's n and r's in the equation. So we've got n as the larger group that we're selecting from. That's that number right there. And we've got the r as the number we're selecting from that larger group, and we get the r's in the denominator there, giving us n combination r as n factorial over r factorial times n minus r factorial. Okay, so let's take a look at an example here. There are 5 desks in the front of the classroom. In a pre-calculus class of 11 students, how many groups of 5 students can sit in the front? So basically right here what we're saying is, if you're sitting in the front, you're sitting in the front. We're not worried about any arrangement of people sitting in the front, right? So if you're a part of that group, you are one of the 5, right? So right here, if we're looking at this, we can say that the number we're selecting from is going to be our 11 students. So right here, n in this case would be 11. And the number of people we're selecting from that group of 11 is going to be the 5 students that are going to fill those 5 desks, right? So right here we've got 11 combination 5. Why don't you guys go ahead and set up this, this equation right here, and we'll come back and look at this in a second. Okay, so n factorial over r factorial times n minus r factorial is going to give us 11 factorial over 5 factorial times 11 minus 5 factorial. And of course, we're going to simplify the subtraction first, which will give us 11 factorial over 5 factorial times 6 factorial. Now right here, if we're evaluating this, we're going to expand out the factorials, but we're only going to expand the 11 factorial till we get to the larger of the 2 factorials in the denominator, because that's the one that we're going to want to cancel. So right here we would say 11 times 10 times 9 times 8 times 7 times 6 factorial over 5 factorial times 6 factorial. And right here what we're going to get is those 6 factorials canceling. And then right here, the thing that we're going to end up evaluating is, of course, 11 times 10 times 9 times 8 times 7 over our 5 factorial, which is 5 times 4 times 3 times 2 times 1. And this gives us 462 possible groups of 5 students to come up and sit in the front row, right? So what we want to do right now is just take a quick look at the formula right here we have for these combinations. What we can see here is that really what we have is very close to the permutation formula, where we have n factorial over n minus r factorial, right? Well, if we were to evaluate this question with the permutation formula, we would basically not only be interested in how many groups of 5 we can get to come up and sit in the front, we'd also be interested in how many ways we can arrange those 5 students in the front. But since we're only interested in how many groups of 5 we can come up and get to sit to the front, we want to divide out all the ways that we can arrange those students in the front. So the number of ways we could arrange 5 students would be 5 factorial, and that's our r factorial. And so right here, if we're going to divide out r factorial, we can divide by r factorial or multiply by 1 over r factorial, and that, of course, gives us our combination equation. So basically what we're saying is it is permutation, but then we're dividing out all of the ways that we would basically arrange those 5 students once they were selected. Okay, so what we want to do now is take a look at evaluating this stuff in the calculator. So right here we can go and check our work in the calculator. We'll go to our calculator, and for our combinatorics we're going to go to math, and we are going to arrow over to probability. And here we're seeing our NPR, our NCR, and a factorial, right? If we want to check our work with the first, second, and third place for the race of swimmers, we can go ahead and select NPR, right? We have 7 swimmers in our race, and right here we're selecting 3 to be first, second, and third. And if we press enter there, we're going to see our 210. And right here, if we want to go back and check our work for the number of ways we can select 5 students to come up and sit in the front, we can go back to probability, select 3 for combination. We've got 11 students in the class, and we're selecting 5 of them to come and sit up front, and that's going to give us 11 combination 5, which is 462. So that's that stuff right there. You can see it in the calculator, and in the end, we'll probably end up using the calculator a lot more than we'll end up calculating all this stuff out by hand. What we're going to do now is take a look at 2 more complicated questions. Basically what we want to do is sort of think about strategy a little bit here. So right here, in our first question, we've got a neighborhood formed a committee constructed with 3 residents from each of 3 blocks. If there are 19 people living on the first block, 24 people living on the second block, and 21 people living on the third block, how many possible committees can be formed? So right here, basically what we want to think is that we want to break this down, right, into a form that we're familiar with. And what I would say is, if we think about selecting those 3 residents from each of the 3 blocks as being a step, right, then we can say the number of ways that we can select 3 members from the first block would be step 1. The number of ways we can select 3 members from the second block would be step 2. And the number of ways we can select 3 members from that third block would be step 3. Right? So right here, what I want you guys to do is to think about how many ways this can happen. Right? Now, what I would say is it doesn't matter what order we select those members in. Right? If you're one of the 3, you're on the committee. Right? So that's the big hint. But basically, this is the multiplication principle of counting. So we're really going to be multiplying each of the ways that these steps can happen. So we'll pause the video now and let you guys give this one a shot. All right, so looking at this, we can basically see that the number of ways we can select 3 members from 19 residents would be 19 combination 3, right? It doesn't matter what order you're selected in, it only matters that you're selected. And basically right here, we're seeing 24 choose 3 for the number of ways we can get 3 committee members from the second block, and 21 choose 3 for the number of ways that we can get 3 committee members from that third block, right? And now right here with the multiplication principle of counting, we're basically just going to multiply all of the ways that each of these 3 steps can happen, right? So right here what we're going to do is take out our calculator and type all this stuff in. So right here we will go to math, over to probability, and then right here we will select combination there. And so first block is 19 combination 3. Now we want to arrow out of the subscript there and multiply that by the number of ways that we can select 3 members from the second block. Oops. So right here we'd go back, I'm going to delete this. And right here we would go back to math, over to probability again, select 3. And so that's going to be 24 residents from the second block, choose 3, or combination 3. And then right here, arrow out of the denominator, and we're multiplying that by our 21, choose, or combination 3 right there. Now right here, when we type all this into the calculator and press enter, we get a really large number. Right here we've got 2,608,470,480 ways of possibly getting a committee, right? So these are all the possible committees we could get, right? Or the number of possible committees we could get. So 2,608,470,480 possible committees we can get from these 3 blocks. Okay, so let's go ahead and look at another problem that will involve the multiplication principle of counting. You and 5 friends are trying to plan a trip to the city over March break, but no one is sure they will go. How many possible groups are there for the trip? Include the possibility no one goes and only one person goes. So right here, what are the stages for our multiplication principle of counting? And what I would say is we can think about each of the friends being a stage, right? So right here, I'm going to actually let you guys think about how to set this up, give it a shot, and we will come back and look at setting this up in a second. And again, right here, we're thinking about the number of ways each friend can make the choice, right? Okay, so give this a shot. All right, so right here, we've got each friend as a step in our multiplication principle counting. The number of ways that the first friend can make the choice to go to the city or not would be 2. They can either go to the city or not go to the city. Similarly, the second friend can make the choice in 2 ways. Third friend as well can either go or not, that's 2. And then fourth friend can either go or not. And then fifth friend, in the end, can either go or not. So with the multiplication principle counting, we've got 2 times 2 times 2 times 2 times 2 gives us 2 to the 5th, or right here, 32 possible groups going to the city, including the group that is the null set of null people, and the group of each individual member, right? So basically, only one friend, one of the 5 friends going. So right here, we will go ahead and stop our video, and we will come back and do some worksheet problems tomorrow. All right, guys, see you tomorrow.